2 weeks ago, two engineers from Anthropic, Prabaker and Andrew Wilson, walked on stage in San Francisco and showed something most people building AI agents are getting completely wrong. They gave their agent one line of input: build a retro game maker. They walked away. 6 hours later, they came back to a fully fledged app. It had named itself RetroForge. It had a 54 color palette nobody asked for. It had a sprite editor, a working physics loop, and an entire AI assistant inside the app that could draw a castle on command. Total cost $200. Same prompt, same model. Solo Claude, the way most people run it, built a screen that looked fine, with arrow keys that did absolutely nothing. The player could not move. That is the gap between using one Claude and using the harness Anthropic actually runs internally. 3 Claudes, talking to each other through files on disk, arguing about what done means, throwing away 10 hours of work when they hit a wall, and shipping things solo Claude never even attempts. I rebuilt their entire setup in Claude Code last night. Every file, every prompt, every slash command, paste ready. By the end of this video, you will have it running in your own terminal. Full credit to Ash and Andrew, link in the description. But what they did not give away on stage is the operator playbook, the exact rubric, the negotiation contract, the 2-tier auto apply rule, the 6 mistakes you will hit in the first hour. I am going to give you all of it. Let's go. First, why does this matter right now and not 6 months ago? Andrew opened the talk with a chart from METR. It plots how long an agent can run autonomously and still complete 50% of its tasks with only a minimal scaffold. A year ago, with Opus 3.7, that number was about 1 hour. By the time of the talk, with Opus 4.6, it was 12 hours. 12 hours of autonomous work. An entire working day. And that was Opus 4.6. We are on Opus 4.7 now. The curve has already pushed further. So you might think, great, the harness becomes obsolete. Just wait for the next model. That is the exact wrong conclusion. Here is the thing Andrew said on stage that you should write down. Every time Anthropic releases a new model, they also release new harness changes alongside it. The harness and the model co-evolve. When the model gets better at one weakness, that part of the harness gets simpler. But a new weakness shows up somewhere else, and the harness fills that gap. The frontier does not shrink, it moves. So the question is never, do I still need a harness? The question is, what is the spiky weakness of the model I am running today? And what is the smallest scaffold that fills it? The people who learn to read that gap will always be 6 months ahead of the people waiting for the model to fix everything. Anthropic's whole talk was a public answer to that question for Opus 4.6 and 4.7. Let me show you what they actually said. Andrew said there are 3 root reasons agents lose the plot on long runs. You need to understand all 3 before any harness makes sense. Reason 1. Context. The context window is finite. So a fresh session has amnesia. As you go deeper into one session, you hit context rot. Coherence quietly degrades. And as the agent gets close to its context limit, it exhibits a behavior they call context sense anxiety. The model gets nervous, rushes to finish, and produces worse and worse work in the last 20% of the session. Reason 2. planning. Out of the box, models are bad at planning. They try to do everything in one shot. They build half a feature and stop. They run out of context and leave a half finished app. Without a planner role, agents drift. Reason 3, and this is the one almost nobody talks about. Models are bad at judging their own work. The same sycophancy that makes a chatbot agree with you applies to coding. The model looks at a half baked feature and says, "Yeah, that looks done." It builds a button with no backend behind it and marks the task complete because the button is there. So, three failure modes: forgetting, half finishing, lying to itself about being done. Anthropic's framing is that you fix the first one with model improvements and you fix the other two with harness design. Specifically, with two ideas: splitting up the roles and forcing the model to argue with itself across separate context windows. That is the single insight that powers the rest of this video. Ash put it in a way I have not been able to stop thinking about. He said the pattern is shamelessly stolen from GANs, generative adversarial networks. You have a generator, you have a discriminator, and you put adversarial pressure between them. One builds, the other grades. They fight. And the result of the fight is the output. Now, the obvious objection is, if the evaluator is also a large language model, why does it not just rubber stamp the generator? They are both Claude. They are both biased toward liking large language model style output. And Ash gave the answer that unlocks the whole technique. Tuning a standalone critic to be harsh is tractable. Tuning a builder to be self critical is not. That is a really important sentence. Read it again. It is much easier to make a separate critic agent harsh than it is to make a builder agent honest about its own work. The analogy he used: it is easy for any of us to critique a fine meal or a piece of art. It is much harder to actually cook the meal or paint the painting. Critics have it easy, builders have it hard. And the same gap exists between a Claude prompted to build and a Claude prompted to grade. So the move is to exploit that gap. Stop trying to make one Claude do both jobs. Spin up a separate Claude with its own context, its own system prompt, its own tools, whose entire job is to be the harsh critic of the first Claude. The split is the win. Everything you are about to see is just operating leverage on that one idea. Ash and Andrew did not stop at two roles. They added a third, a planner. So the final org chart inside the harness is three Claudes: a planner, a generator, an evaluator. If you squint, it is the same shape as a tiny software team: PM, IC, QA. They did not invent that. They just gave each role its own context window, its own system prompt, and its own tools. Here is the anti cascade rule that took me 3 reads of the talk to fully appreciate. The planner does not plan technical details, it plans sprints, high level chunks of work, a list of features, a roadmap. That is it. Why? Because if the planner tries to spec the granular technical decisions upfront and gets even one of them slightly wrong, that error cascades through every single sprint after it. Multi-hour run, multiplied error. So the planner stays high level on purpose, and the technical decisions get made later by the generator and the evaluator in the context of the actual code. PM thinks in sprints. IC writes the code. QA breaks the code. 3 contexts, 3 system prompts, no cross contamination. The unlock here is mental. Once you start thinking of one agent as one role, not as one Claude, the whole architecture clicks. You do not run agents. You run an org chart. And the org chart has a shape. Planner at the top, generator and evaluator at the bottom, with adversarial pressure between them. Everything else in this video is the wiring. Here is the move that made me sit up. The piece Ash called the glue between the generator and the evaluator. Before the generator writes a single line of code, the generator and the evaluator have to negotiate what done means. They argue on disk. Through markdown files, the generator proposes, I will build feature X and you should verify it by testing Y. The evaluator pushes back. Actually, the scope is too big. Those tests are too weak. You missed these three edge cases. The generator revises. They go back and forth until both agents agree on a written contract. Then and only then does building start. And when the build finishes, the evaluator does not grade against the planner's original spec. It grades against the contract that the two of them wrote together. Ash said the retro game maker contract had 27 specific criteria in it. Not 3, not 5. 27. Why does the number matter? Because vague criteria produce vague critiques, and a vague critique tells the generator nothing it can act on. Granular criteria say, this exact line is wrong. Here is the test that proves it. Fix this. The agent knows what to do. This is the part the Ralph loop never had. Ralph loop took a fixed plan markdown and ran the model in a loop against it. Nobody on the other side argued. Nobody pushed back. The contract is what turns a loop into a debate. And the debate is what catches things solo Claude misses. Like the fact that the backend button has no actual backend behind it. Now let's build it. Here is the entire file tree you need in your project to run this harness in Claude Code tonight. 6 files. That is it. At the root, 1 Claude.md, which is the harness charter. It tells Claude that work in this repo is done by 3 roles and points it at the role files. Then a folder called .claude/agents. Inside, 3 markdown files. Planner.md, generator.md, evaluator.md. Each one is a full sub-agent definition with a harsh, narrow system prompt that we will write out in a minute. Next, a folder called .harness. Inside, you create contract.md, which is empty at the start. The negotiation between generator and evaluator writes into this file. And progress.json, which tracks which sprints are done. Important detail Andrew called out on stage. Use JSON for state files, not Markdown. Their team found that Claude is much more likely to silently overwrite a Markdown state file, but is well behaved with JSON. So contract.md, fine, because both agents read and write it. But progress, sprint status, feature lists, all of that, JSON only. Finally, a slash command at .claude/commands/longhorizon.md. That is the driver. When you type /longhorizon inside Claude Code, it runs the entire negotiate, build, evaluate loop. 6 files, 1 folder of subagents, 1 folder of shared state, 1 slash command on top. That is the entire surface area of a long-running harness. Now let's fill each of those files in. Start with the evaluator, the critic. Because Ash said this is the role that matters most, and the one Claude is worst at by default. Out of the box, Claude is a terrible QA agent. It is sycophantic. It finds a bug, says fix it later, and marks the task done. So, your job in the evaluator system prompt is to fight that. Here is the structure I use, lifted directly from the talk. The evaluator gets a harsh system prompt that says it is a senior staff engineer with no tolerance for AI slop. It has access to Playwright MCP or Claude for Chrome MCP, so it can actually open the app in a real browser, click around, take screenshots, and report what it sees. Not what the diff says, what the running app actually does. Then it has a 4-part rubric: design, originality, craft, functionality. Ash said they deliberately weight design and originality higher than functionality because Opus 4.6 is already good at functionality. And the real failure mode now is purple gradient AI slop. The fix is to calibrate the rubric with few short reference examples. You give the evaluator 3 websites that look great and say, this is the bar. You give it 3 sites that look like AI slop and say, this is what to reject. The evaluator's taste converges on your taste. And here is the part nobody tells you. When the evaluator scores low on a criterion twice in a row, the harness does something extraordinary. It tells the generator to throw away the whole thing and start over from scratch. Ash said they expected this to be rare. It happens all the time. The evaluator is the only role with the authority to demand a teardown. Solo Claude will never voluntarily delete its own work. The critic will. Now the other 2 roles. The planner gets the shortest system prompt of the 3, and that is on purpose. Its job is to take a 1-line user prompt and turn it into a list of sprints. Each sprint is 1 or 2 sentences. Not a technical spec. Not a list of files to create. Not an API design. A sprint says, build the basic UI shell with these 3 views, or add the play mode with these inputs. That is the right level. The system prompt explicitly forbids the planner from making technical decisions. The whole anti-cascade rule Andrew talked about lives in this one constraint. The generator is the workhorse. Its system prompt says, you are an optimistic builder. Your job is to write code that satisfies the contract you negotiated with the evaluator. You have full file system access. You can run tests. You cannot mark a sprint complete unless the evaluator says you can. That last line is what stops it from rubber stamping itself. The generator can do whatever it wants, except declare victory. Only the evaluator can do that. One more detail that took me an hour to debug the first time. The planner writes its sprint list into a file called sprints.json. The generator picks the next undone sprint from that file when it starts work. Why JSON? Same reason as progress. Claude does not silently rewrite JSON the way it sometimes silently rewrites Markdown. Use it. State that matters has to live in JSON. Now the slash command that ties it all together. /long horizon. This is the full body of the harness in one file. When you type it in Claude Code, here is what happens. Step 1. The planner subagent reads your prompt. Writes sprints.json. Hands off. Step 2. For each sprint in order. The generator picks the sprint and proposes a contract. It writes its proposal into contract.md, step 3. The evaluator reads the contract proposal, pushes back, rewrites contract.md with sharper criteria. The two ping pong until the contract file stops changing. That is the convergence signal. Step 4. The generator builds against the contract, runs tests, commits. Step 5. The evaluator launches Playwright, opens the app, clicks around, scores against the rubric, writes a critique. Step 6. If the score is above the threshold, mark the sprint done in progress, .json and move to the next sprint. If the score is below the threshold, twice in a row on the same criterion, the harness invokes the teardown rule. Generator deletes the relevant files. New sprint. Fresh attempt. Step 7. When the last sprint is done, the harness runs one full end-to-end evaluation across the whole app and writes a final report. The whole loop in one slash command. Cost you nothing. Runs as long as you let it. Internally simple. Externally feels like magic. Ash said their full retro game maker run was about $200 and 6 hours. That is what those numbers buy you. Now, the 6 mistakes you will hit in the first hour and the fix for each one. I hit 5 of these. The 6th is from the talk. Mistake 1. You try to make solo Claude its own critic, asking the same agent to also grade its work. It will not work. It is structurally sycophantic. Spin up a real subagent with a separate system prompt. Mistake 2. You trust compaction to preserve coherence. Ash was explicit. Compaction does not equal coherence. Lossy summaries drift. Long runs need shared state on disk, not a smushed context window. Write to files. Read from files. Treat the context window as scratch space. Mistake 3. Your rubric is vague. You wrote things like, the app should look polished. That gives the evaluator nothing. 27 specific criteria beat 3 vague ones every single time. Mistake 4. You let the planner spec technical details. Then the smallest planner error cascades through 6 hours of work. Force the planner to stay high level. Sprints, not files. Mistake 5. You store state in Markdown. Claude silently overwrites it. Use JSON for everything stateful. Markdown only for human-readable artifacts like the contract. Mistake 6. The big one from the talk. You stop reading the traces. Ash said the primary debugging loop for the entire harness was reading what the agent actually did, finding where its judgment diverged from human judgment, and tuning the prompt at that spot. Not running more experiments, reading. He even shared a trick. Pipe the agent transcripts into files and have another agent grep through them and propose prompt edits. Close the loop on the harness itself. 6 mistakes, all easy to skip, all eventually fatal. Here is your start tonight checklist. 5 steps. 1. Create the 6 file scaffold I showed you. Claude.md, 3 subagents, 2 state files, 1 slash command. 2. Write your evaluator first. Calibrate it with few short examples of good and bad. 3. Start with a tiny test prompt, like build a calculator with a history view, before you try to one-shot a full app. 4. Read every single trace from the first run. Look for where the evaluator wimped out. Tune that spot. 5. Only after one full successful run, scale up to a real project. I packaged the entire setup into a free PDF called the Long-Running Agent Operator Playbook. 10 sections. The 3-role org chart with when to use 2 versus 3 versus 4 agents. The full negotiation contract template. Paste ready Claude. Md. Paste case ready evaluator subagent with the 4 criterion rubric. Paste ready planner and generator subagents. The full/long horizon command. Every line. The trace reading playbook with the agent grading agent transcript trick. And 7 mistakes plus fixes, including the one from Anthropic stock. To get it, comment the word loop below this video. I will send it to you. Quick reminder: subscribe does not equal follow on Facebook. On Facebook, subscribe is the supporter button that is paid. On YouTube, subscribe is free and tells the algorithm to send you more videos like this one. If you are building agents in 2026, the operators who learn to run them for hours instead of minutes will own this market. Subscribe early. Win early. Comment loop. Hit subscribe. I will see you in the next one.